Two couples, Adam Brenda and Carl Darlene, have bought tickets to see a musical. And how many ways can the couples be seated if the men do not sit together? On first blush, this looks pretty much like a standard permutation problem, but there's a wrinkle here because the men can't be seated together. That makes it a little different. One thing you could do is just brute force it and do a tree diagram. I'm going to try something that's sort of equivalent to that, but maybe has a little more thought behind it. I'm going to break it into cases because if the men can't sit together, you can't have man-man in any of those combinations, but you can have female-female. So the two women can't sit together at the beginning of the rows because that'd be female-female, it mean male-male at the end, nor could they sit at the end because they'd start with two males. So even though the problem doesn't say that the females can't sit together, they can't sit together just anywhere. The only way they can sit together is if they're between the males. So the way I'm thinking about this, I'm looking at the problem as having two possibilities. The first possibility is that the two women, I'm going to say females to say F. I'm going to try to stick with that. The two females sit together between the two males. They can't sit at the beginning of the row because that'd force the men together. They can't sit at the end of the row for the same reason. But if the females sit together, they would have to sit between the two men. That's one possibility. Now let's look at the implications of that. If the two females sit together between the men, let's call them F1 and F2. It doesn't matter what their names are. The two females could sit with F1 on the left of F2. That would force you either to put male 1 to the left and male 2 to the right, or you could leave the female sitting in that exact same position, but you could put the second male in the left chair and the first male in the right chair. So that's two possibilities. But the two females in the middle could be switched themselves. In other words, you could have female 2 on the left and female 1 on the right. If you do that, the first male could be on the left and the second male on the right, or again keeping the females just where they are, you could switch the males and have male 2 on the left and male 1 on the right. So there are four ways that the females could sit between the males together. But that's only one possibility. The other possibility is that the females don't sit together. Now, if the females do not sit together, that means they're going to alternate with the males. So you've got female-male alternation. That's the only other possibility. If the females don't sit together, that means the males and the females have to alternate. So let's think about that. If the females alternate and the first female sits in the first chair, first seat, you can't have the two females together in the beginning. We've already gone over that. That'd force the two males together. So that means that the second female would have to sit in the third position. Right? If they alternate, you can't put the two females together. So if given that position, the first male could go in between and the second male could go on the right, or you could leave the females in exactly the same position they're in and switch the males so that the second male went between and the first male went on the right. Now I said the females and males have to alternate, but I didn't say the females had to come first. So here the females were alternating in the first and third position, but they could also alternate in the second and fourth position. In other words, you could have a male to the left of the first female and then a male between there. Or you could leave the females exactly where they are, and you could alternate the males so that the second male went to the left and the first male went between. Okay? Now, am I leaving anything out here? I said the two females sit together between. There are 4 ways. The two females do not sit together. Yeah, see, I've alternated them between sitting first and third or second and fourth, but I've actually left out some possibilities. I could also switch, so even if the females are sitting the first and third position, I could have the second female sitting here and the first female there. And that would generate 2 more possibilities, with the first male sitting here and the second male sitting there. And again, keeping the females exactly where I had them, I could switch the males and put the second male between and the first male on the right. Once you see that, you can see I've done the same thing here. I've always put the first female in the second and the second female in the fourth, but that doesn't have to be. The second female could be in the second and the first female could be in the fourth position. If I did that, the first male could be on the left and the second male could be in between, or again leaving the females right where they were, I could put the second male to the left and the first male in between. And so I get 4 ways for this to happen, with the females being in 1 and 3. And I get 4 more ways with the female being in positions 2 and 4. So altogether I get 4 plus 4 plus 4 equal 12 ways. You do have to think about it, and I sort of did this on purpose. I almost skipped over those, and I did it sort of on purpose here to kind of make you think that you can't turn your brain off here. You really have to think and make sure you've listed every possibility. And if there's any reason why a tree diagram might be preferable to this, it would be that very reason. It's a little harder, I think, to leave out cases if you actually draw a tree diagram. So look at that quickly, and I don't have room to do the tree diagram on the same page with this one, but let's get rid of that and do a tree diagram and see if we get the same answer. So let's try it now with a tree diagram. I think I'll make it kind of horizontal. I believe I've got more space the way I work it that way. Let's let this be the first chair. Well, if I do the first chair, I can put anybody I want there. I can put the first male in the first chair, or I can put the second male in the first chair, or I can put the first female in the first chair, or I can put the second female in the first chair, or the first seat, however you want to say it. Okay. Now, once I've chosen, let's go back to the left. If I've chosen the first male to go in the first seat, I can't put another male there because the males can't sit together. So if I did that, I'd have to branch out and put either the first female in the second seat or the second female in the second seat. Now let's just keep moving down those branches. Suppose I put the first male in the first seat and the first female in the second seat. Now the females can sit together in the middle, so I still have two choices. I can either put the second male in the third seat, or I can put the second female. Remember, the females can sit together, it's just the males that can't. And once I go down this first branch, I've chosen everybody now except for the second female, so in the last position I'm forced to choose the second female. If I go down this branch with the first male, the first female, and the second female, I'm left with the second male that hasn't seated, so the second male would have to seat there. Now let's move down this branch where I've chosen the first male and the second female. Now I've got a choice of either one. Anybody that's left can sit in the third position. I can either put the second male in the third seat, or I can put the first female in the third seat. But once I've chosen the third seat, the fourth seat is fixed. So if I've got male 1, female 2, male 2, then all I haven't seated in that row would be the first female. And if I go down this branch, I've got male 1, female 2, female 1, so I haven't seated male 2, so male 2 would have to be seated. Okay? Now let's move and look at what happens if the second male is seated first. Well, it's the same as before. I can't have a male sitting next to a male, so when I split, I have to either choose female 1 or female 2. If I choose female 1 going down this branch, then I can put anybody that hasn't seated next. So I can either seat the first male, or I can seat the second female. Once I seat 3, the fourth person's determined. So if I go down this branch, male 2, female 1, male 1, I haven't seated female 2, so female 2 has to sit. Male 2, female 1, female 2, male 1 hasn't sat, so I have to seat male 1. Now going down this branch, if I seat male 2 followed by female 2, again, I can seat anybody that hasn't seated yet in the third position. So I'm either going to seat male 1 there, or I'm going to seat female 1 there. But once 3 are seated, then the fourth is determined. So if I do male 2, female 2, male 1, I haven't seated female 1, so female 1 would have to sit. Down this branch, I've seated male 2, female 2, female 1, but I haven't seated male 1. Okay, continuing the process. If I seat female 1 in the first seat, I can't seat the two females together in the beginning, because that would force the two males together at the end. So if I seat female 1 here, I have to either seat male 1 next or male 2 next. Now if I choose female 1 and male 1, I can't choose male 2, because that would put male 2 next to male 1, so I'm forced to choose female 2, and once I've chosen all 3 of those, I have to choose whoever's left, and that would be M2 to sit in the fourth position. And going down the F1 M2 branch, I can't choose another male because they'd be sitting next to each other, and I've already chosen the first female, so I'd have to choose the second female, and once the second female is chosen, the only person that has not been seated is the first male, so I'd have to choose that person. And finally, I could choose the second female for the first seat. Again, I can't put the two females together at the beginning, because that would force the two males together at the end. So I have to split, just like in the previous one, either the first male, second female. And from there, I can't put the two males together, so that forces me to choose female 1 here, which forces me to choose male 2 here. And going down the last branch, if I've chosen female 2 and male 2, I can't put the males together, so I have to choose female 2 there, which forces me to choose male 1 there. And that's it. And if you count them, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different ways, just like before. The two methods are really not that dissimilar. The tree diagram, I think, forces you to consider every possibility, maybe a little bit more than doing it the other way, but I could be wrong about that. It's really your preference. The first way, to me, takes a little less work, but not significantly so.